2-1 is functions and graphs. You need to? You think it works better for you? Wasn't your best? Okay, well, let's try paper. Okay. So we are going to be talking about functions and graphs today. First thing you need to know about is called a relation. Think about a relationship, right? That's between two people, like a romantic relationship between two people, or a friendship, a relationship between two people. So a relation is a set. It doesn't last? Is that what you said? False. I have been happily married for 14 years, and we dated for 5 before that. 19 years with the same man. Fantastic. Okay, thank you. I'm nowadays. Are you calling me old? I'm nowadays.
When you were in college, that's when people. Did you guys meet?
Okay. Anyway, yes, relationships. This is a set of pairs of input, okay, and your input values are your x values, and output, which are probably what?
Y.
Good job. Yes. Values. Okay, a set of pairs of input and output values. So x's and y's that relate to each other, okay? There are 4 ways to represent a relation, and I'm going to show you all 4 in more of a chart form. I'm going to use a ruler. That's not straight. All right, so you can have any of these 4 ways. That is not straight either. All right, so the first is you can have an ordered pair, or ordered pairs, plural, because it's a set of pairs. You can have a mapping diagram. Do you guys remember doing mapping diagrams in Algebra 1? You might when you see it. We'll see. You can have a table, or you can have a graph. Okay, all of these will show a relation. So I'm just going to give you the same relation 4 different ways so you see how they all look. Okay, if they do it by ordered pairs, we'd have -3, 4, 3, -1, 4, -1, and 4, 3. Okay, that is my set of x and y's that are related to each other. So that's if we see it as ordered pairs. If we see it as a mapping diagram, you take your x's and you put them in this column. You take your y's and you put them in this column. But with a mapping diagram, we don't use any duplicates, and we put them in order. Okay? So if we're looking at our x values, if you look at your ordered pairs here, that's all of these guys. That means my mapping diagram is going to be -3, 3, and 4 on the left, because we don't use duplicates, so there's 2 4s, we only write one of them. And then on the right side, we have a 4, a -1, a -1, and a 3. So we put them in order. So that's going to start with -1, and then 3, and then 4. Okay? Now the way a mapping diagram works is we take those ordered pairs and we connect them, because it's going to tell us if we have a function or not, which I'll get to in a little while, but this is how it can look. So -3, 4, you draw a line from the -3 to the 4. 3, -1, you draw a line from the 3 to the -1. 4, -1, you draw a line from the 4 to the -1. And 4, 3, you draw a line from the 4 to the 3. I'll come back to that in a little bit, how we know if something is a function or not, but that's what a mapping diagram looks like, okay? Then we also have a table set up. You could do a table, and if you do a table, it's gonna look like this. So you have -3, 4, you have 3, -1, you have 4, -1, and you have 4, 3. Okay, and then the last would be a graph, and this is not going to be a perfect graph, but you will get the idea at least. 1, 2, 3 back, 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so if I were to plot these points on a graph, I have -3, 4 is going to be up here. 3, -1, so you're going 3 to the right and 1 down. 4, -1, 4 to the right and 1 down. And then 4, 3. Okay, so those are all different ways that you can represent a relation. You have done every one of those before, I promise you, okay? Unless your algebra teacher didn't teach you all the algebra, but this should be it. If you went to Valley, I know you did all this because I've taught that Algebra 1. Okay, so with this, there's 2 different parts to it. There's the domain and there's the range. Can anyone tell me what the domain is?
In the domain, the numbers.
Someone said it over here. It is numbers. Which numbers? It's the x, okay? Your domain is your x's, or sometimes we call them our input numbers, the numbers we're going to put into a function. Those are your independent variables. In other words, they are what are going in. They don't get affected by anything else. It's just, here's a number, we're going to put it in, okay? Your range, then, is your y's, which are your output numbers. So you put an x in, you get a y out of it, okay? So that's your output numbers, and y's are dependent. They depend on whatever your x value that went in was, okay? Now, when we do domain and range, like I said, we will always put them in order and do no repeats. So if there is a duplicate, we don't write the duplicate number, okay, for domain and range. All right, so here's your first example. I want to know the domain and range of the sample above. Okay, your domain, and we usually put them in brackets. What is the domain for that problem above? I pretty much gave it to you in one of those setups.
-3, 3, 4.
-3, 3, 4, right? This here, the mapping diagram, gives you your domain and your range, okay? No duplicates. Put them in order, so -3, 3, 4. So what's your range?
-1 through 4.
-1, 3, 4. Okay, questions on that? Yeah.
So when you're doing the mapping diagram, do you always write them in order from least to greatest?
I always do, because that's how, like, Algebra 1, we've always done it. I don't know in the book that they did in order from least to greatest, but I would say put them in order from least to greatest. Yeah.
Just to keep it organized.
Just to keep it organized and to make sure you didn't miss something, and yeah. Yeah, I would leave it in order.
Is it always going to be like domain is X and range?
Yes, domain is always X, range is always Y. Yep. Good? Okay. So that is going to lead us to talking about a function. I'm going to write out the definition for you, I think. Do you want a definition? I'm going to write it out. You don't necessarily need to write this out. If you already understand what a function is, that's fine. But for those of you that need a definition, this is your definition, okay? So it's a relation in which each element of the domain, so that's your x, right? Each of your x's, each element of your domain corresponds to exactly one element of the range. And the range is your what?
Y.
Your y. Okay. In other words, if we go back up, let me just show you up here real quick. Sorry, you're still writing, I'm sure. If we look at the mapping diagram up here, in order for something to be a function, you cannot have a repeating x value. For instance, in this mapping diagram, there's two arrows coming off of the 4. That is not a function, okay? You cannot have 4, 3, and 4, 7, and 4, 6, and say that's a function. It cannot have a repeating x value. You can have repeating y values. You cannot have repeating x values. Does that make sense? Okay? We'll just make a little note of that. No repeat x values. Okay? For a function. So here's my question. Example number 2 here. I want to know, is it a function? Just so you know, I often abbreviate function like that. So if I write FN, I mean function, okay? So is it a function? I'm going to give you a few samples here. Let's say we have -3, 0, 4. So I'm doing a mapping diagram. -2, 1, 7. And my setup looks like this. Is that a function?
Yes.
Why?
Because they don't go to the same ones.
You have no repeating x value, right? No x is going to multiple y's. So we would say yes. There are, oops, that says no, sorry. No repeating x values. Okay, how about this? So we're going to list coordinates here. 4, -1, 8, 6, oops, 1, -3, 6, 2, and 4, 1. Is that a function?
No.
Why?
Because 4 is -1.
Because the 4 is used twice, right? So we would say no, this is not a function. 4 has 2 y values. Okay, yeah.
Did you say that the y can repeat and there would still be a function?
The y can repeat and it's still a function. The x cannot repeat and be a function, okay? Okay, and here's a good indicator of where this happens. Do you guys remember the vertical line test from Algebra 1?
Oh, I don't remember that. It sounds familiar, but like I don't remember.
Okay, this one, vertical line test is super easy. If you can put a vertical line through a graph and it only hits one point, it's a function. If there's anywhere on the graph where you hit 2 points vertically, it's not a function. So the vertical line test, let's just do a few to show you. Let's say I have this graph. Okay, the blue is my graph. Is that a function? Yes, I can put a vertical line anywhere here. Vertical line here, 1 point. Vertical line here, 1 point. Vertical line here, 1 point, 1 point. Anywhere vertically that I go, I'm only gonna hit 1 point on my graph. Okay, so we would say, let's just back up here. We would say yes, oh no.
Oh,
I
man.
backed up too far. Try again. So this would be yes. It passes the vertical line test. Okay? How about this one? Bless you.
No.
No, because if I draw a vertical line through right now, I hit 2 points. If you draw a vertical line and you hit 2 points, the answer is no. Okay? How about this one?
No.
Maybe tough to see, but
Yes.
we're going to say those both hit. Just points. I'm just plotting points on a graph. This would not be a function because it doesn't pass the vertical line test, right? I can put a vertical line and hit 2 points at the same time. Okay? Last one of these, not last problem. How about that? Is that a function? Yes. I can put a vertical line anywhere here and I'm only going to hit 1 point at a time. Are we clear on vertical line test? Okay. So we're going to do a lot of function notation. Basically a fancy way of saying how you write a function. Function notation is this. You will have an equation, y equals 3x plus 2, where this is your input and this is your output. Okay, function notation would be to write it like this instead. Okay, what you do is you make your y and f of x. We're saying the function of x or f of x. Okay, so when you see this, think f of x. Okay, the function of x. If I plug x in for something, what do I get out of it? The way we often write it then, so say my input was going to be 1 and 2. I would say f of 1, in other words, if I'm plugging 1 in for x, would be 3 times 1 plus 2. So f of 1 is 5. Does that make sense? It's just a different way of writing y. Okay? So if I were to do f of 2, what does that mean for the rest of my equation? You're just plugging in 2, right? So it's going to be 3 times 2 plus 2. So it's going to be 6 plus 2. So f of 2, in other words, the function of 2, when I plug in 2 into the function, I get 8. Okay? That is function notation. It's really not any different than saying y equals. It's just saying, here's the number I plugged in and here's the number I got out. You're seeing your x and your y value. Okay? Okay, so, I thought you were taking a picture. Let's say, example 4 here. The question is this: what is the output for the inputs -3, 0, 1/4? Okay, for this function, f of x equals negative 2x plus 5.
Is the function always fx plus b?
No. A lot of the time, right now. But eventually we'll do a lot of different functions. So do you understand what I'm asking you right here? What is this asking you to do? Plug in the x's, see what you get for the y's, okay? So you're going to say f of what? Negative 3, okay? That's going to be your input. F of negative 3 equals negative 2 times negative 3 plus 5, okay? We simplify that, so f of negative 3 is 6 plus 5, or 11, okay? Then we do f of what? So we did negative 3. Now you're going to do 0. F of 0 is negative 2 times 0 plus 5. 0 plus 5 is 5. Okay. Last one, f of 1/4. So negative 2 times 1/4 plus 5 makes f of 1/4. So negative 2 times 1/4 is a negative 1/2 plus 5 would be 4.5. Or you can write it as 4.5, however you prefer. Okay, so that would be your outputs, 11, 5, and 4.5. If you really want to get fancy and do technically your range, right, you'd go 4.5, 5, and 11.
Do we have to do that?
No, I think on these ones I'll let you just leave it in this format. Yeah, Will.
Why green 0 plus that there again?
Say that again. Why?
Why?
Oh, why did I cross these out?
Yeah.
I was just showing that I had already calculated them. Yeah, you don't need to cross them out. I was just showing, like, we've done the negative 3, we've done the 0, now do the 1/4. All right, last question. Oh. Example 5. It says concert tickets are $35 plus a handling fee. Why do they always have to have handling fees, right?
Well, do you get them in front of the concert?
No,
That's
it's
definitely a handle fee.
definitely doesn't have an does or
You know
doesn't?
the guy who buys like 30 tickets and sells them in front of the concert.
Oh, yeah, no. This is, I'm just saying, buying it online. It's like, oh, handling fee of $8 because you bought them online. Come on. Anyway, here's what we're gonna do. Okay, we're gonna write a function that models the cost, which we're going to call C. Okay, so we're going to write a function that will help us figure out the cost, because what if we wanted to buy 8 tickets versus if we wanted to buy 50 tickets, right? A function would help us figure out the cost of that. So we're going to set this up. Because cost is going to be C for us, we're going to say, thank you, we're going to say C, and then just to keep it so that you know what you're talking about, okay, I would call, instead of C of X, I would say C of T, because we're talking tickets, right? T is your input, the number of tickets is your input. What would that look like for the rest of the setup?
2.5x plus 35. Or 2.5t.
The other way. 35T, right? It's $35 per ticket, so 35 times the number of tickets plus that one-time handling fee of $2.50 that nobody knows where that money goes to. So that would be your function, okay? So then we're gonna evaluate for 4 tickets. So if we're gonna buy 4 tickets, what's the total cost gonna be? So you're gonna set that up. The cost of 4 tickets is 35 times what? Times 4, right? That's your input, the 4, plus 250. And then you just simplify that. So 35 times 4 is 140. So the cost of 4 tickets is 140 plus $2.50. So it'd be $142.50. Math you will use so often in your life. Every time you buy tickets or every time you buy fill in the blank for
I mean, we don't have.
X number of people.
Yeah,
What?
automatically covered.
Yeah, you just hit like quantity amount and like select how
Oh,
many.
you guys are just lazy. Don't be lazy with your math.
Or you could just.
Figure it out.